Hope you all are doing fine. So today we will be doing 1.3 crystal growth. So what we will be doing in this one, we'll first see 1.3.1, which is obtaining ultra pure silicon. So we first know that silicon is when we use silicon in this diode, in this semiconductors, the silicon is very pure. I mean, yeah, we will soon study that. Okay, there we will be doing doping, etc. But right now we'll be looking at how we can obtain ultra pure silicon element or silicon crystal. So silicon is specially made material. Basically, silicon you can find it in numerous compounds, but the fact remains the same that you can't just find only silicon. So you can't find only silicon, so there will be compounds of silicon like silica. Main two compounds we can find in the atmosphere and on planet Earth, which is silica, which is impure silicon dioxide, and second is silicates, which is silicon plus oxygen plus another elements. Now, to produce device quality silicon, a silicon that we can use in our devices, what we have to do is that we have to go through, the silicon has to go through some steps. First is we have a silica. Then what will happen is that we do this process where we reduced in presence of C. We put the silicon in the presence of C and reduce it, and then we find a very impure silicon after silica, and then what we do is chlorinate it. We'll do chlorination, or we'll chlorinate this silicon, which is very impure silicon. Now what we find is silicon tetrachloride, which is SiCl4 liquid. We find this compound in liquid form, and what we do is we distill, and then we find ultra pure silicon, this tetrachloride, which is in ultra pure form, which is not like in this situation where silicon can also have hydrogen with chlorine and silicon. After this step we find a very ultra pure SiCl4, and then what we do a reduced in hydrogen atmosphere. We take this whole material, and then we reduce this in hydrogen atmosphere, and then we find ultra pure polycrystalline silicon. Now notice here also we have done all this process, but we have only got it ultra pure polycrystalline. So here also silicon is not a pure crystalline in nature, but in polycrystalline, like here we can see. So what in the last step what we are doing is we have SiCl4 plus 2H2O, and then we got 4HCl and silicon. So this silicon that we got is polycrystalline in nature. And we have 1.3.2, which is single crystal formation. Here the silicon we have found is actually a polycrystalline. So there are many crystals, or I can say there are multiple patterns in one crystal. So it becomes polycrystalline because there are different variation in this one single crystal, therefore it's polycrystalline. But now how will we get single crystalline formation? So for this, the book has a pretty much very nice diagram in which you can see this whole process happening. So the method we use to yield single crystalline of silicon is called Czochralski-Pult method. My pronunciation might be wrong, so please look into that. So we have found ultra pure polycrystalline silicon using this method. Using this method, we have found this polycrystalline silicon. Now we place it in a quartz cubicle and heat it in an inert atmosphere to form a melt, as shown in figure 1.8. So you see figure 1.8 is in the book, and it is very clear, the diagrams and the step. Then what we have, a single crystal or silicon seed crystal with the normal to its bottom face carefully aligned along a predetermined direction. either it's in this direction 111 triangular brackets, or it's in triangle 100, and this bracket is then clamped to a metal rod and dipped into melt, and then some more steps. So basically this process, single crystal formation, you can go through it again because the book has the diagram and that's there defining it. So I didn't go much into it because I didn't feel like it's very important from the perspective of a syllabus, plus it's not something that we can do and try it out on ourselves. We need to have all of this kind of a procedure which we can only done in very expensive labs. So me I talked we discussed, basically me and my professor and some class students. So she was telling us about the fact that it is not at all easy to make silicon. It is very expensive, but still we have to use silicon because its thermal properties are very good. Like silicon does not melt at very high temperature, so that's why we use silicon, because it is good at that quality, and other metals are not that good as compared to silicon. And this whole process that they are talking about in the book, which in under the topic single crystal formation, this process happens in huge labs and very clean labs, and those are very expensive labs, etc. In summary, just few points, that semiconductor are ultra pure, or we make them pure, and they are highly ordered material, and atomic bonding scheme inside the diamond lattice. So these are all of the things we basically studied. So that's all for the chapter 1. See you guys in next chapter, carrier modeling.